Summarizing the problem solving section. To efficiently solve problem solving questions, you need to have strong fundamentals. Mathematical topics and the concepts should be very strong. Sometimes, if you are not able to think of the correct approach to the question, you can try the option fitting route. This route can help you quickly get to the correct answer. Please make sure if you exceed the 2-minute mark, skip the question by marking randomly. This applies to especially the problem solving sections. If you have no clue what the question is about, it's better to skip the question and save that time for some another question which may require large amount of calculations. Next, we move on to data sufficiency. Let's solve a question. A certain library assesses fines for overdue books as follows. So there is a rule that is given for calculating the total fine. On the first day that a book is overdue, the total fine is increased by $10. Let's just say it's $10. For each additional day that the book is overdue, the total fine is increased by 0.3 or doubled, whichever results in the lesser amount. What is the total fine for a book on the 4th day that is overdue? So to solve these type of questions, we create a table which indicates the day and the fine. On day 1, the fine is $0.1. For each additional day that the book is overdue, the total fine is increased, so we have a condition here. How do we get this? Now, we have a condition that the total fine is either increased by 0.3 or doubled. If we increase 0.1 by 0.3, we get 0.4, or if we increase 0.1 and make it double, we get 0.2. Whichever results in the lesser amount is the fine. The comparison between 0.2 and 0.4 gives us fine as 0.2. Similarly, for day 3, the fine is calculated as 0.4. How do we do that? Doubling 0.2 gives us 0.4 and adding 0.3 in 0.2, which is day 2's fine, gives us 0.5. Comparison of 0.4 and 0.5, the lesser amount is 0.4. But what about day 4 now? Doubling 0.4 gives us 0.8 and adding 0.3 gives us 0.7. Here 0.7 is the lesser amount and hence we put 0.7 as day 4's fine. The correct answer is second option. These type of questions are very common in the GMAT exam. Do practice these questions from the official guide. For a certain race, 3 teams were allowed to enter 3 members each. A team earned 6 minus n points whenever one of its members finished in nth place, where n is between 1 and 5. So this says that we have a total of 9 members in teams A, B and C, and the total points earned are in the order 5, 4, 3, 2, 1, and every other person earned 0 points. There were no ties, disqualifications or withdrawals. That means the points were allotted to one person each. The total points become 15 when we sum it all. The question asks, if no team entered more than 6 points, what is the least possible score a team could have earned? How do we calculate this? Let's assume team A to have the least points, and we create a map out of it. In order to have the least number of points for team A, we need to give team B and team C the maximum number of points that they can get. Since our problem states that no team can earn more than 6 points, we give B and C exactly 6 points. As we discussed, the total points are 15, and giving B 6 and giving C 6, we get a total of 12. The remaining 3 must go to A. Hence, the fourth option, which is 3 points, is the correct answer. Of the following integers, which is the closest approximation to root 3 plus root 5 whole squared? So to solve this question, we need to remember one identity that we learned in our high school, which was a plus b whole squared equals a square plus b square plus 2ab. Using this identity, we can easily solve this question. Let's see how. Applying this identity on the question and putting a equal to root 3 and b equal to root 5, we get root 3 whole squared plus root 5 whole squared plus twice of root 3 into root 5, which gives us 3 plus 5 plus 2 root 15. Now, to calculate root 15 by hand during the exam becomes a very difficult task, and hence we use a trick known as approximation. We know that 4 square equal to 16. So root of 15 would be somewhere near to 4. Let's say I take the value of root 15 at approximately 3.8. Using this, I get the value of root 3 plus root 5 whole squared as 15.6. Since this is closer to 15, our correct answer would be 15. Now, if we also check it by calculator when we are practicing, we can get the correct answer very near to what we have got right now. This is a pretty simple question and can be easily solved in the exam. Let's understand the question. The question asks, does 2m minus 3n equal 0? So we need to solve for a condition. Looking at option number 1, it says m not equal to 0. Can we infer 2m minus 3n is equal to 0 from m not equal to 0? How do we find it? M can be, let's suppose, 1. If m is 1, n becomes 2 by 3. Which is not 0. But if suppose we say that m is 3 and n equals 2, in this case the equation becomes 0. In both these situations, m is not equal to 0, but we are getting two different options in this. Hence, statement 1 alone is not sufficient to answer the question. We can easily cut off question number part 1. Now, we move on to statement 2. Statement 2 says 6m equal to 3n. Looking more closely on this, we can divide the equation by 3 on both sides to get 2m equal to 3n. Now, taking 3n to left hand side, we get the equation that is given to us. 2m minus 3n equals 0. Statement 2 is clearly able to solve our question, which is always gives us the answer as true, that is 2m minus 3n equal to 0. So statement 2 alone can satisfy the problem. Statement 2 alone is sufficient to solve this problem, and hence we won't look at the other options. This is a fairly simple question to be solved in GMAT, and these type of questions only go wrong if you make a silly mistake, and that happens if you are stressed out in exam. So I would recommend you to keep your concentration levels extremely high during the exam, and that will enable you to solve these easy questions very quickly, giving you time for the tough questions. This is a question of counting. If n is a member of the set 33, 36, 38, 39, 41, 42, what is the value of n? So now we are given some conditions from which we need to find the value of n. Let's look at statement number 1. Statement number 1 says n is even. When we are talking about n being even, we can easily eliminate out the odd values out of it. Do remember that we are calculating for statement 2, we do not consider n is even condition. Hence, we create a set for n is even, that is 36, 38 and 42. For these three, can we find n uniquely? No, we can't. We have three options for statement 1. Hence, statement 1 alone can't be. Hence, statement 1 alone can't solve the problem. Looking at statement 2. Statement 2 says n is a multiple of 3. Creating the set for n being a multiple of 3, we get 33, as 33 is a multiple of 3. 3 into 11 is 33. 3 into 12 gives us 36. 3 into 13 gives us 39. And 3 into 14 gives us 42. So set 2 gives us 4 values of n. Checking it alone, statement 2 alone is not sufficient because we have 4 values which can be put in statement 2. Hence, statement 2 alone can't solve the problem. Now, we look at statement 3, 4 and 5. Since they are not sufficient alone, option 4 gets cancelled out and we are left with option number 3 or option number 5. Now let's consider both of these questions together. When we are thinking of a value of n out of this set where n is even as well as a multiple of 3, we look for common elements in set 1 and in set 2. 36 is one common element in both and 42 is one common element in both. That is, both 36 and 42 satisfy equation 1 as well as equation 2. Together, they both are not able to prove or give us a unique value of n, and hence they both together are not sufficient, which gives us the correct answer, that is, statement 1 and statement 2 together are not sufficient. Had there been only one answer after taking an intersection of these two sets, we would have selected option 3. But since we have two options for n, we will go with option number 5 since we cannot uniquely find the value of n. This is a tricky question, but if you have practiced these type of questions before, you will be able to solve this question in the exam very easily. A sum of $200,000 from a certain estate was divided among a spouse and 3 children. So there are 4 people in total in which the sum has been divided. How much estate did the youngest child receive? So there are 4 people and we need to calculate the amount that the youngest child received. Looking at statement 1, it says the spouse received half of the sum from the estate and the oldest child received 1/4 of the remainder. So the spouse would have received $100,000 and out of the remaining amount, that is another 100,000, the oldest child got 25,000. But does this give us the amount that the youngest child received? I don't think so, because we have 2 children and $50,000 need to be divided among these 2 children, and there is no mention of how the money is divided among these 2. Hence, statement 1 alone can't answer this question. Since statement 1 is alone not sufficient, option number 4 gets cut out as well. Now we look at statement number 2. Statement number 2 says each of the younger children receives 12500. Each of the two younger children receive 12500 more than the oldest child and 62500 less than the spouse. So after reading this, it may sound a bit confusing, but if you start off by taking the value that each of the two younger children received as x and make linear equations, you will get this. X and x being each of two younger children, x minus 12,500 being the amount received by the oldest child, and x plus 62,500 received by the spouse. How do we get to this equation? Each of the younger two children received 12,500 more than the oldest child. That means if the younger child had x, the oldest child had x minus 12,500. Similarly, the younger child got 62,500 less than the spouse. That means the spouse would have got 62,500 and x. Through this equation, we can easily find out the value of x, and hence we can find out the amount that the youngest child received. Statement 2 alone is able to solve the problem, and hence the correct answer is option number 2. This question might seem a little tricky at first, but if you have certain practice, if you have seen these type of questions before, which you will definitely find in the official guides, you can easily solve it in the exam. This is one of my favorite questions. A bookstore that sells used books sells each of its paperback books for a certain price and each of its hardcover books for a certain price. So we have two different type of books that the bookseller is selling. If Joe, Maria and Paul bought books in this store, how much did Maria pay for one paperback and one hardcover book? Whenever we have two different types, we divide them and identify them each as a variable. Let's assume paperback as x and the hardcover as y. So, statement 1 says Joe bought 2 paperbacks and 3 hardcover books for $12.50. This is the equation that we get. Now comes the very tricky part. Statement 2 says Paul bought 4 paperback books and 6 hardcover books for $25. For $25. Forming the equation, we get one more equation. So we have two variables and we have two equations. If we look at statement 1 alone, that is 2x plus 3y equal to 12.5, can we deduce the value of x plus y, since we have to calculate x, one paperback, and y. X plus y has to be found. I don't think so, because when we have two variables, we must have two equations in order to solve for x and y respectively. Statement 1 alone is not sufficient to answer this problem. And since statement 2 follows a similar pattern and similar structure as statement 1, statement 2, that is 4x plus 3y, cannot solve the problem alone. Option 4 gets cancelled out because each statement alone is not sufficient. Now, this part is easily mistaken. When I was solving this problem for the first time, I made a mistake. I saw two equations. I thought two variables. I know I can find the value of x, I can find the value of y, hence together they will be able to solve the problem. But the tricky part here is, if you divide the second equation by 2, you get 2x plus 3y equal to 12.5, which is the same as equation 1. This means when we thought that we had two equations, we were actually having only one equation. This is a very tricky question and many people get mistaken in these type of questions. Since we have only one equation right now, which is represented in two different forms, that is, multiplying equation 1 gives us equation 2, we cannot actually solve for the value of x and y from these two statements. Hence the answer is 5 and not 3. One more point that I would like to add upon here is that if we had an equation, for example 6x plus 6y equals some value, let's say suppose 36, as one of the statements, we could have definitely divided the whole statement by 6 and could have got the answer. with one equation only, because we have been asked the value of x plus y and not x and y separately. But since we have only one equation here from which we cannot actually find out the separate values by either multiplying or dividing the equation by any number, we look at the second equation, which once again is actually this first equation itself. This is a very tricky question, and you must practice these type of questions and have a great concentration during the exam to get these type of questions correct. Happy learning. After practicing these data sufficiency questions, we now summarize what we have learned from these questions. A very simple and good trick for data sufficiency questions is to evaluate both statements as individual statements without thinking of the correlation. Do not think of statement 1 while evaluating statement 2. And if no conclusion is drawn through individual statements, consider the statements in a combined form and solve. The biggest trick for these questions, try evaluating statement 2 first. This is one trick that worked for me very well. By evaluating statement 2, I am able to eliminate two options while also avoiding that confusion or the mix-up that my mind can generate when I am evaluating it in the perfect 1 and 2 order. By evaluating statement 2, I am not at all focusing on statement 1, and I am solely and only focusing on statement 2, and through this I am able to eliminate two options or maybe even get to the correct idea or the approach for the question.